Writing code that works is only half the job. The other half is knowing it still works after you change it. Go's testing story is one of the things that distinguishes it from most languages. There's no testing framework to install, no configuration to write, no test runner to choose. You run Go test and your tests run. This episode covers how Go testing works, how to write good tests, and the table-driven pattern that Go developers use almost universally. Go's testing is built into the toolchain. The testing package ships with the standard library, no third-party dependencies needed. You create a file ending in test.go, write functions starting with test, and run Go test. The toolchain finds everything automatically. The naming convention does real work here. Files ending in test.go are excluded from normal builds, they never ship in your binary. Test functions starting with test are automatically discovered. You don't register them anywhere. There's no configuration file mapping tests to packages. The naming is the registration. A basic test function takes a single argument, testing.t. That's the test controller. You use it to log messages, report failures, and control test execution. The simplest test calls the function under test, checks the result, and calls t.errorf if something is wrong. Errorf works like fmt. Sprintf, it takes a format string and arguments and formats the error message for you. The test file is in the same package as the code under test. That gives it access to unexport functions and types, useful for testing internals. If you want to test the public API only, you can use package maintest in the test file, same directory, different package name. Go test in a directory runs all tests in that package. Go test / runs tests in all packages recursively, what you'd run in CI. The V flag is verbose mode. Without it, Go test only prints output for failing tests. With V, it prints == run test name and pass or fail for every test. Use V when you're debugging. Leave it off in CI output unless you want pages of green text. Run takes a regex pattern and filters which tests to run. Go test run test add runs only functions matching that name. The same flag works for subtests. Go test run test add /positive runs only the positive subtest. This is invaluable when you're iterating on a failing test. You don't want to wait for unrelated tests every cycle. Count =1 disables test caching. By default, Go caches test results. If the code hasn't changed, it reuses the last result. This is usually what you want, but sometimes you need a fresh run. Count =1 forces it. The t-testing.t parameter is your interface to the test framework. The key distinction is between error and fatal variance. t.errorf reports a failure and continues. The test is marked failed, but execution keeps going. You'll see all the failures in one run. Use this when remaining assertions are still meaningful even after a prior one fails. t.fatalf reports a failure and stops the test immediately. Use this when continuing would be dangerous or pointless, like if you can't open a database connection or a file doesn't exist. There's no value in running further assertions if setup failed. t.log prints a message, but only shown in verbose mode or when the test fails. Use it for debug information you want visible when things go wrong but not during normal runs. t.skip marks the test as skipped and stops it. Use for tests that require external services or platform-specific tests that can't run in CI. t.helper is subtle but important. When a test fails inside a helper function, the error message normally points to the line inside the helper, not to the call site where the problem actually originated. Calling t.helper as the first line of any helper function tells the testing framework to report the error at the caller's line instead. Always do this in assertion helpers. Table-driven tests are the idiomatic Go testing pattern. The idea is simple. Define a slice of test cases as an anonymous struct, then range over it running the same test logic for each case. The struct fields are whatever the test needs. Inputs, expected outputs, a name string, flags like want_err. Every field is explicit. When a test case fails, you see exactly what was tested. The tt.name field is passed to t.run, which creates a subtest with that name. This is the key move. T.run turns each table entry into a named, independent test. Each one has its own pass/fail status. One failing case doesn't stop the others. The naming is deliberate. TT is conventional for table test. TT inside the range loop refers to the current case. The function in T.run gets its own T-testing.t, the subtest controller, not the outer tests. The structure forces good habits. Because all test cases share the same struct definition, you can't add a field to one case and forget to add it to the others. They're all in the same slice literal. If you need to test a new input or a new output condition, you add one entry to the table, not a new function. T.run does more than name the test. Each subtest runs independently. A panic in one subtest doesn't abort the others. Each subtest's output is labeled separately in verbose mode. And each subtest is addressable from the command line. Run a single case. Go test run test add/positive. Run all cases matching a prefix. Go test run test add/negotiable. The slash separates the outer test name from the subtest name. This is one of the most useful flags you'll use day-to-day when debugging. When multiple subtests are running and one fails, the output shows exactly which case broke. Fail. Test add/mixed. You don't have to guess which iteration of the loop failed. The name is right there. Go functions that can fail return an error as the last value. Testing those functions means verifying two things: that the function succeeds when it should, and that it returns an error when it should. The wantErr bool field in the test table handles both cases. When wantErr is true, the test checks that an error was returned and returns early. It doesn't check the value because the value is meaningless when there's an error. When wantErr is false, the test checks that no error was returned and then checks the value. This pattern covers the full contract of an error-returning function in one table. You don't need a separate test divide errors function. The error cases and the happy path cases live side by side, making it easy to see the complete expected behavior at a glance. One thing to avoid: don't check the error message string. Error messages are implementation details that change. What matters is whether an error was returned at all, and sometimes whether it's a specific Sentinel error using errors.is or errors.as. Test main is the escape hatch for package-level setup. It runs once before any test in the package runs. You call m.run to execute the tests and pass its return value to OS exit. Without the OS exit, deferred calls in test main would run, but the process exit code wouldn't reflect test results. Use test main for things that are expensive to set up and shared across all tests. Starting a test database, creating a test server, seeding fixtures. For per-test cleanup, use t.cleanup. T.cleanup registers a function to run when the current test, or subtest, ends, whether it passes or fails. This is the right way to clean up resources that a test creates. Temp files, open connections, goroutines. It runs even if the test calls t.fatal partway through, which a deferred function inside the test would also do. The advantage over defer is that t.cleanup works across helper functions. You can register cleanup from inside a helper, and it still fires when the test ends. T.parallel tells the test runner this test is safe to run concurrently with other parallel tests. It's called at the start of the test function or subtest function. The typical use is in subtests. Mark each subtest as parallel to run all the table cases concurrently. This can dramatically speed up tests involving I/O or slow operations. The one classic mistake: loop variable capture. Before Go 1.22, ranging over a slice reuses the same variable. If you launch a goroutine inside the loop without capturing first, tt equals tt, all goroutines end up with the last value of the loop variable. In parallel subtests, this causes subtle, non-deterministic failures. The fix is to add tt equals tt before the t.run call. In Go 1.22 and later, each loop iteration gets its own variable, so the explicit capture is no longer needed, but it doesn't hurt. Go testing is built into the toolchain test.go files, test functions, go test to run. The testing.t API covers failure reporting, error/FATELF, logging, skipping, and t.helper for clean error locations. Table-driven tests with t.run are the idiomatic pattern. Define cases as a struct slice, range over them, and use subtest names to identify failures. The want_error pattern handles error-returning functions cleanly. Test main handles package setup. T.cleanup handles per test teardown. Next episode: benchmarks, test coverage, mocking, and testing best practices. This course is based on The Complete Guide to Go Programming, available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 20.